So when we're talking about the idea of a circuit, okay, a circuit is nothing more than taking power from somewhere and transferring it to some kind of object to make it do something. And it creates a loop from the power supply out to a variety of things back to the power supply. So a circuit is kind of like a cycle, okay? Now there's several things that all of our circuits that we're going to learn about need. First and foremost, we know that circuits need power from somewhere. Okay, we are going to be using electrical power supplies. These little boxes that we're going to plug into the wall, and they're going to tell us how much voltage is coming out of these power supplies. Okay? So this is what the symbol looks like for a power supply. So if I've got a circuit, and I'm going to keep drawing this little circuit on the side, okay, I don't even care what's in my circuit, but I am going to have an actual power supply there, positive and negative. Okay, that shows me in a circuit, that could be a battery giving off energy. We are going to use electrical power supplies, okay, to set the number of volts coming out of it. This is the symbol. So in addition to something to give the circuit power, well, the whole point of having a circuit is to do something with different objects within the circle. Case in point, a light bulb or a ceramic resistor. Okay, a light bulb is a resistor. It's a type of resistor. So we will say that all circuits need one or more resistors in them. We're going to give two symbols for resistors. Even though a light bulb is a resistor, we're going to show the symbol for a light bulb, but we're also going to show the general symbol for a resistor. So the first symbol here is the light bulb, the one with the big loop. And then the one with the squiggly lines, just a common symbol for a resistor. And this symbol, the squiggly lines, makes sense because what does a resistor do? It makes it harder for the current to go through the object. It slows the current down. So I look at this as being an obstacle course. That current, instead of just going from here to here, it's got to kind of go through a maze to get to the other side. It's more work. Okay? So resistors, yes. What else? So in order for that energy to go from the power supply to the resistor to let it do something, well, we need to have a link between the two, and that is wires, metal wires that are encased in plastic. So the two main things that we can measure with tools in a circuit is the potential difference going through that circuit or being used up by each of those resistors, and we can also measure the intensity of the current. We can measure current intensity. Okay? So voltmeter is what we use to measure the potential difference, which is in volts. When you're drawing a voltmeter will never actually be part of the loop that is the circuit. It will always be surrounding something. So it will be at the start here and the end, and it has a V in it. Okay? It is outside of what we call that circle of friends. It's on the outside trying to get in. Okay? That is the voltmeter. Now we also talked about current intensity. And current intensity is measured in amps or amperes. So we have an ammeter that measures current intensity. Now, unlike the voltmeter, the ammeter is part of the circuit. So we will just have those wires. We will have our ammeter linked up and it carries on. So to draw you a simple circuit here, a simple circuit is something that only has one resistor. Let's draw the actual, what a simple circuit would look like. So first and foremost, we'll start off with our power supply. Okay? And that wire will actually go out of the power supply. And I'm going to put my ammeter here. Notice how I'm keeping the same color scheme, because the ammeter is part of the circle of friends. So when we finish the loop, so the reason the voltmeter on the bottom is in a different color is because it's not part of that loop. It is not part of the actual circuit. Its job is to go on the outside of the circuit to measure the voltage that individual resistors take up. So here's the question. If there is only one resistor in a circuit, will that resistor take all the voltage or only a portion? It will take all the voltage. There's nobody else to share it with. Okay?